All right, guys, so here we are at the top of the hour. We are going to get started. My name is Matt Shell, aka Matt Mirrorfish. I am the newest member of the Learn team here at Unity. So today we're going to do a session about creating a flying hover car. You know, this might be something similar to like a car that you would see in something like Wipeout. And we are going to keep this on a fairly basic level. So this should be helpful for people who are just getting started or at the beginner level or haven't worked a lot with physics. We're going to be doing some fairly basic C# scripting to get this kind of flying car controller. And we're also going to have a little bit of fun with audio at the end to give this car an engine sound, just to give it a little bit of polish. We're going to start with a little gray box prototype, and then we will add in a 3D model from the sample assets pack, and we'll add in the audio at the end. So the way I'm going to run the session is I'm going to do a bit of stuff, and then I'll break for some questions to kind of keep you guys moving along. So we'll do a little stop and start and give everybody a chance to catch up and ask the questions that they have. While I'm talking, I will probably not be looking so closely at the chat, but I will pause to check out what you guys are asking. And we also have the incomparable Adam Buckner on board tonight in the chat room. So thank you, Adam. So let's just dive right in. What we're going to do, I've got a empty Unity project here that is initialized for the 3D defaults. And so if you just create a new project, you're not going to have to do anything special. Just give it a name and save it. Now, we're going to start by setting up just a really rudimentary environment for our car to drive around in. So we're going to throw in some ground and some little sort of fake buildings just so that we can have some context and kind of detect the movement that's going on. So we're going to just start by creating a 3D object, a cube, and we're going to make it pretty big. Let's do 10,000 by 1 by 10,000. That's just going to fill out our ground, and we will label that as such. This is going to be called ground. And then we're going to make some buildings, which are just going to kind of give us a little bit of a context reference so that we can tell that we're moving, not just looking at this kind of blank plane. So we're going to create another 3D cube, and we are going to label that building. And this will be, let's say, maybe 200 by 500 by 200, and we'll move it up 250 units on the y-axis so that it's kind of sitting there on top of our cube. Let's just move it a little off the origin because that's where our car is going to be. And then we're going to go ahead and just duplicate a bunch of these to make our kind of low-budget cityscape here. So we'll just go ahead and we'll do 4 of those. And then another 4. And another 4. So I'm duplicating by highlighting them in the hierarchy. And using, I'm on a Mac, so I'm doing Command D. This will be Control D on a PC. And let's see, let's make 4. And then we'll just Shift click to select all of these, and we'll just slide them around a little bit just to make a little zone for us to drive around in. We'll throw these guys over here, and maybe throw those over there. Next, just to give us a little lighting in the scene, we're going to go ahead and create a light. In this case, a directional light. And I'm actually going to drop the intensity down a little bit because we're going to go for a kind of a moody nighttime feel here. So I'm going to take it down to 0.2. And then just to kind of clean up our hierarchy, because we've got a lot of stuff sitting in it now, we're just going to create an empty game object, which we will call environment. And we're just going to child all of this stuff to that. This is really just kind of serving as a sort of a folder in the hierarchy so we can just kind of get all that stuff out of view. And next, we're going to make our placeholder car. Let's go ahead and create a cube at 0. And this will be 2 units wide, 1 unit tall, and maybe 5 units long. And we can scroll in, there it is. And let's actually move it up to 3 units on the y-axis, so it's above our plane here. And next, so this is what we're going to use to kind of represent our car before we get the model in. I want to focus on the scripting first, and then we can kind of do some fun stuff with setting up the model in a second. But so we're going to be adding physics forces to this, so we're going to need a rigid body component. So I'm going to go down here, click Add Component, and if I just type RIG, we can see that our rigid body will appear. We're just going to click on that to add that component. And we're going to start with some default values here. We're going to have a drag value of 1 and an angular drag of 0.5. Now, these are just some values that I kind of hit on during testing. You can kind of season to taste with these once we get the script working to kind of give your car a little bit of a different driving feel. But for now, we're going to start with those. Now, let's just give this a quick test to make sure that's working. We'll play our scene. Boop, and our car will fall down to the ground, which is what we want. And so that is good to go. Next, we're going to start getting into some scripting. So what we're going to do is we are going to create a new C# script. Before we do that, we'll create a folder. So I'm just going to go Create Folder, and we'll call this Scripts. In our scripts folder, we're going to go ahead and create a new C# script, and we're going to call this Hover Motor. This is what's going to be providing the movement, and so next we're going to open that up in MonoDevelop. Let me zoom in the view here. Make it nice and big. Let's see how that looks. And so we're going to start by declaring some public variables. We're going to have a public variable of the type float called speed, and I'm going to initialize this to 90. That was just a number that I found. And then we're going to go ahead and add a public float called turn speed. Now, turn speed, about that camel case. And so speed is going to be what we're going to be moving forward along the z-axis, and turn speed is going to be the speed that we're going to be rotating around the y-axis from left to right. And next, we will declare two more public floating point variables called hover force and hover height. Now, we're going to use these to push our hovering vehicle off the ground once it gets to be a certain height distance from the ground. So we're going to have another public float, and this is going to be called hover force, and it's going to be equal to 65. And then we're going to have a public float called hover height, and this will be equal to 3.5. Next, we're going to declare some private variables. Now, I'm going to explicitly type in the private keyword. It's not actually required, but I find it can be helpful to make your code a little bit more readable. So we're going to have a private float called power input, a private float called turn input, and a private rigid body called car rigid body. We're not going to use the start function, so we are going to switch it to an awake. And in awake, we're going to go ahead and get a component reference to our rigid body component. Now, this is something that you want to pay attention to that is coming in Unity 5, but we're going to be eventually the rigid body shortcut is going to be deprecated. So we're going to get into the habit of just getting these component references in our scripts now. So we're going to say car rigid body, get component, rigid body. And from here on out, we're going to use car rigid body when we want to act on the rigid body. So next, we are going to get some input. So we're going to go ahead and we're going to say power input is going to be equal to input dot get axis vertical. So we're going to use the WS and the up and down arrows to drive our craft forward and backward. we're also going to set our turn input to equal input.getAxis horizontal. And that's actually all that we're going to do in update, because the rest of our code is going to be happening in our fixed update loop, because we want it to be moving in step with the physics time step as opposed to the frame rate, right? And for those of you for whom this is new, the reason that we don't want to do physics stuff in the update function is because the frame rate can vary, right? If we have a lot of graphical stuff happening on the screen at one point, the frame rate may drop, and we don't want our physics objects to start moving more slowly because the frame rate has gone down, and that's why we will use our fixed update loop to do things like apply physics forces. So we're going to go ahead and in our fixed update, we're going to start by declaring an array called ray, and that is going to be equal to new ray. So the origin is going to be transform.position. So we're going to be casting a ray from the position of our transform, from our craft, and the direction that we're going to be casting it in is going to be negative transform.up, aka down. Once we've got that, we're going to declare a raycast hit called hit. And next, we're going to go ahead and cast that ray and use it to check if we are within our hover distance, our hover height of the ground. And if we are, we're going to push ourselves away from the ground by applying some physics forces. So we're going to go ahead and say if physics.raycast ray out hit hover height. So we're going to cast our ray. Whoops, don't need that. And if we are within the distance hover height, we are going to go ahead and do the following, which is that we are going to push ourselves away from the ground, and we're going to do it in proportion to the distance to the ground we are. So we're going to push with a different amount of force depending on the height that we're at. And this is just going to give us a little bit of a smoother kind of hover action. And so to do that, we're going to declare a floating point variable called proportional height. And that is going to be equal to hover height minus hit dot distance divided by hover height. So this is just going to give us a floating point value that we're going to use to represent the height, and that we can multiply our force by, so that we can modify it based on our distance from the ground. And we're going to do that now. So we're going to declare a, oh yeah, you're right, I am missing a clothing parenthesis. You know, I pretty much do that every time. Thank you, Rakuru. Thank you. And okay, so next we are going to have this is why it's good to have other people watching you code, right? You can point out your punctuation mistakes. Okay, so we are going to declare a vector3 called applied hover force. We're going to set it to equal vector3 dot up times our proportional height and our hover force. So we're going to scale our hover force based on the proportional height, and then we're actually going to apply it to the rigid body. So next, we're going to say car rigid body dot add force, applied hover force, and we're going to use force mode dot acceleration. And what this is going to do is ignore the mass of the car. And I just found that this was giving us a better sort of hover action but you know, you could play around with this as well and see what works for you. Lastly, so that is going to cover our hovering, right? So we're going to cast a ray down, check to see our distance from our ground, and then depending on how far away from it, we're going to push back from it at different degrees of force. With that in place, and actually we could just save and test that out before we add our last bit of code. So if we hit play, and it falls to the ground, of course, because our cube does not have our hover motor yet. Woo. There it is. Okay, very nice. It can't go anywhere yet because we haven't added that. And of course, let's label this cube car. And okay, and so then just the last couple of lines. Now that that's in place, we're just going to add the force that we got from our keyboard input or from our input, right? It doesn't need to be a keyboard because we're using input.getAxis. So we're going to say car rigid body dot add relative force, and that is going to be 0 along the x, 0 along the y, and power input times speed along the z or z axis for all you non-American people. And next, we're going to say, for our turning, car rigid body dot add relative torque, right? Physics-based rotation, 0 turn input times turn speed. So we're going to rotate around the y-axis so that we can turn left and right. Save that. Let's just have a look at the chat here. How is +1 for louder? You really want louder keyboard hit sounds? I might be able to give those to you. Yeah. I could just, you know, hit the keyboard with a hammer maybe. I'm a firm believer in the traditional mechanical keyboard, so that is not going anywhere. Okay, so next, let's just give this a quick test. And so, woo, zoom. We can zip around the screen and fly off into the distance and lose track of our car. So let's just quickly child our main camera to the car, right? So it will follow the car, and I'm going to go ahead and let's set it to maybe 2, so it's a little bit above. And the last thing that we're going to do is we're just going to constrain the rotation of this. We don't want it to rotate around the x or the z axis. And this is where our buildings, whoa, clipping city, right? This is where our buildings come in handy so we can actually tell that we're moving once the camera is attached. And let's just go and adjust our far clipping plane. Let's make it really long, 5,000. So we can see all our beautiful buildings as we fly around, and we can kind of get that impression of movement. And so there we go. So that is the kind of the most basic gray box prototype version of this. Cool. So now we've got this in place. Let's go ahead and kind of fancy this up a touch. Let's add in a 3D model. So I have here the asset store, which you can access by going to Windows Asset Store. And then in the search box, you're going to type in sample assets, which will get you to this screen. And I've already downloaded them. Very good. Okay. So I have here the sample assets. This is a bunch of models, sound scripts that you can use for your games and for your prototypes. And we're going to use this sexy orange car here. And so I've already downloaded this, which is why I have an import here instead of download. But if you have not downloaded this, you're going to see download, and you're going to need to wait a few minutes or seconds to download. So I'm just going to go ahead and hit import. Now we're not going to grab all of this stuff. We're just going to grab a couple of things. We're going to get the car. All right. And I'm going to just go ahead and hit none, turn everything off, because really all we want is down here at the bottom, this car folder. And we're also going to get in the aircraft section, we're going to get the audio subfolder. This is actually not, if we wanted to use the car properly, we should also grab multi-platform input scripts, but because I'm just going to take all the scripts off the car, I'm not going to worry about that for now. But if you do want to use the car, make sure you grab those, or you could just pull everything in. I'm going to hit import, and it's going to cook for a second, and let me just take a look at the chat. Yeah, exactly. So it's a good question about extending the clipping plane. If we had lots and lots of complex geometry that would now all had to be rendered in one frame because we raised that distance, we might see a performance hit, or lots of different stuff with different materials would up our jaw calls. But in this case, since I've just got a bunch of gray boxes, I can get away with it without really any major performance loss. But yeah, it is something, you know, it depends on how your level is laid out. If you have a more confined level, you can get away with very short distances, whereas here I've just got this big flat open thing, and so, you know, it makes more sense to go for a longer distance. Okay, cool. So let us continue. So now I'm going to go into my sample assets folder, vehicles, car, prefabs, and we're going to grab the car prefab and chuck it into the hierarchy. Let's just move it up a little bit because it's embedded in the ground. Move it up to 3 where our cube is. And we're just going to actually grab some of the components from the cube. We are just going to grab our rigid body settings. So we'll just say copy component. And we're just going to paste component values onto the rigid body that was attached to the car. And we're also going to grab our hover motor script, copy component, and we're going to add that. Now the car has lots of nice and excellent, so we're going to paste component as new because that component didn't exist on the car already. Now the car has many excellent scripts on it already to make it act like a car, but since we're making a hover car, we're not going to use any of them. So, and these scripts here that come up as missing are because I didn't load the, I forget what it's called, multi-platform input controls. So we're just going to remove them, and we're actually going to remove all of the other scripts starting from the bottom. If you start from the top, you'll get an error saying we need those scripts. So we're just going to start from the bottom here and remove. Okay, so this is what we should have on the top level of our car, just a rigid body and our hover motor script. At this point, we can grab the camera, child it to the car, and our cube, which has provided us great service, can be retired. Now, if we check out our car, let's just make sure it's working. Woo! It's hovering and it's flying. So that's pretty cool, right? But let's just do one or two things to make it more hoverish, and also to prevent any funny stuff. We've got these wheel colliders, which are useful when we're sitting on the ground, but not useful when we're flying around. We're going to delete those. And we're going to go in here to the model, and we're going to mess with the wheels. So we're just going to grab our front left wheels, and we're going to set them to -90 rotation. So now we've got this kind of cool flying car kind of thing going on. And grab the right wheels and set them to +90. And then we've also got these mud guards, which we are going to set to -90 and +90. Just to be clear, this has absolutely no effect on the functionality of the car. It only looks cool, and yeah, just for fun, really. Okay, so now I'm going to take it out for a spin. So pretty cool, right? We've got our flying car. It can fly around. But the last thing that I think would be kind of fun to have here is some sound. And if you've played with the car demo out of the box, you'll notice it has these nice engine sounds which pitch up and down based on how fast the car is going. And so I kind of wanted to have some sounds like that for this car, but of course those are based on the car moving on the ground, and so it didn't work. So I created a new script to do them for our hover car, and that's what we're going to create now. Actually, before I move on to that, let me just read the chat for a sec. Can you make the car green? You totally can make the car green. Should we do that? That's a good idea. Let's do it. It would be faster if it's red. I don't know. I kind of like green. Yes, let's do it. Actually, here we are, right? I happen to be on. Let's go to our paintwork, and we go to Sky Car Paint. And since the first request was for green, let's go for like a pale mint green. Very delicious. Look at that. Ooh, very nice. Okay, cool. Now we're cooking. So let's add our sound to this car. So here on the car object, we are going to add an audio source. And in that audio source, we're going to add our jet engine clip. This is the reason why we imported the sounds from the jet, from the plane, so that we can have a non-traditional engine sound for our flying car, because it is, after all, flying. So double click on that to load it in, and then we're also just going to make sure that it is set to play on awake, which is the default, and we're going to check loop so that it will loop. And let's just hear how that sounds real quick. Awesome. Much more exciting, right? So we've got our sound, but it just kind of loops and doesn't really do anything exciting. So we are going to write a little script which is going to cause it to change pitch based on how fast the car is going. So let's go over to our scripts folder and hit new C# script, and we will call this hover audio. And open it up in MonoDevelop. And what we're going to do is we're going to declare a couple variables. So we're going to have a public audio source, which is going to be called jet sound. And we are going to have a private float. And let's actually just type out private, just so everybody can be clear about what we're doing. A private float called jet pitch. Next, we're going to have a private constant float called low pitch. We're going to capitalize it because it's a constant, and it's going to be equal to 0.1. We're also going to have a private constant float high pitch, which is going to be equal to 2. So what those are going to do is those are going to be the upper and lower pitch limits for our sample. I put it at 0.1, so it would have a kind of an idle level. And we could try it out with 0. You can hear how it sounds, but I just kind of liked it a little better clamping at 0.1. And we'll do that in a moment. And then we're also going to have a private constant float called speed to revs, which is going to be equal to 0.01. And that is going to be just a scaling value that we're going to use to bring the velocity, which we're going to use to drive the pitch and just to bring that into a usable range. We're also going to have a vector3 called my velocity and a rigid body called car rigid body again. And with those in place, we can switch our start to awake, and we're going to get a component reference for our rigid body again. So we're going to say car rigid body is equal to get component rigid body. And then we actually don't need update. We're going to use fixed update. We don't need this either. And let's just try to make this a little prettier. There we go. So we are going to have a private void fixed update. And so the first thing that we're going to do is we're going to say my velocity is going to be equal to car rigid body dot velocity. So we're going to get the velocity from the rigid body. How fast is the rigid body moving? And we're going to use that. We're going to kind of process it a little bit and then use that to drive the pitch. Now, the potential issue with this is that the velocity value that we're getting from the rigid body is in world space. So we're going to need to convert it to local space for our object so that we don't get weird behaviors. So the next thing that we're going to do is we're going to say float forward speed is equal to transform dot inverse transform direction. And what this is going to do is basically convert from world space to local space, and we're going to pass in our car rigid body dot velocity, and what we're getting is the velocity on the z or z axis. So we're going to convert that to local space relative to the car. So next we're going to have a float called engine revs, and this is going to be equal to, so we're going to do mathf.absolute. So because we could be getting a positive or a negative value from our rigid body velocity, if we're moving backwards, we'd get a negative value, and we don't want a negative pitch value for our audio source. So we're going to use mathf.absolute to make sure that whatever value we're getting, it's going to be a positive number, and we're going to use that to process forward speed. Forward speed is not the best name for that variable, but hey, because it could also be backward speed, right? And we're going to multiply that by our speed to revs constant. So really here, I just found in playing with this that I was getting values between something like 0 and 200. And so by scaling it by 0.01, I can bring it down into the range that's kind of useful for applying to the audio source pitch. And so next we're going to actually apply this to the pitch of our audio source. So we're going to say jet sound dot pitch, our audio source jet sound, the pitch of that is going to be equal to mathf dot clamp, right? So this is where we're going to start using our low pitch and high pitch values. We're going to clamp it between, so the value that we're going to clamp is going to be engine revs, and the minimum is going to be low pitch. The maximum is going to be high pitch. So we're going to clamp between 0.1 and 2.0. Now, you may be wondering, why didn't I just write 0.1 and 2.0 right here, since I'm not really changing them in their constants? And that's just because we want to kind of avoid putting magic numbers in our scripts. And this way we can know, okay, these are the constants. If we want to tweak them, we can just tweak them up here and not have to go searching through the code. Not that there's a lot of it here, but you know, in a more complex project, it's kind of a best practice. Okay, so that should be good. Hopefully I didn't miss any parentheses this time. Let's give it a try. We're going to take our hover audio, add it to our car by dragging and dropping, and then we're going to drag a reference from our audio clip to our jet sound public variable so that those two can, so that the script can control the audio source. And let's give it a try. So you can hear there is our 0.1 pitch, right? You can hear the sound is pitched down, and then when we press forward, we can have that nice kind of jetting motor-like sound. And so there we have it. Now, just for fun, just to make this a little bit cooler, let's just go and change up our render settings. We'll switch our ambient light to black, and we'll turn on a little black fog just to give it a little mood. We're going to set the fog density to 0.001, quite low density, but it just adds a little bit of nice ambiance. And then, of course, we're going to take our make camera and set the background to black as well. Now, this is going to get pretty dark, so we'll grab our headlights and let's just set the range to huge, 1,000. Totally unrealistic, but awesome. So now we've got our kind of moody nighttime flying car scene. And since we're not really getting a lot of juice out of the hover action, we could just add a little, let's just add like a little sweet jump in here as well. This will be 100 by 100. And we'll just take this and give it a tiny bit of rotation around the X. And let's back it. Well, actually, let's move it forward. See how that, I'll move it down a little bit. There we go. A little sweet jump there for our hover car so we can see the, woo! Boing. And so, yeah, that is our demo for today. You know, you could take this in a bunch of different directions, but hopefully this just kind of gives you some ideas for your own things. And let's take some questions. But yeah, you guys should totally be able to replicate on your end. You know, this sound file is in the sample assets. It's the jet engine sound. And yes, thank you for pointing out that I have a null reference exception. That is correct. It's not a showstopper, but basically it is. There's a couple more pieces here. The suspension has some. The suspension has a couple scripts, and there's also the brake lights have some scripts, and they're looking for the car controller and can't find it. So we just need to take those off. Thank you for pointing that out. That should be. Oh, still something missing. What am I missing here? Oh, the mud guards, of course, yeah. There we go. I'll get rid of the mud guards, too. Good. Should be good, right? Yeah, there we go. No more exceptions. No more red. You forgive me. Thank you. You are too kind. Yes, hairdryer for the win. Yeah, it totally is possible. What would be the best way to do that? You could add torque along those axes when you're and use the values from. You could add torque along the z-axis, I guess, and then use the value that you're getting from get input horizontal to do that. And Calaverax SC2, you know, if you're interested in gear, this is specifically a not realistic car because I want to keep it pretty simple, but if you're interested in a gear-based version of this, you should look at the car script that comes, the car script that I used for this, that I took those scripts off. Those have some gear-based action in them that you could check out. This is not like, you know, Gran Turismo here. Here, and I'll put the, if anybody wants, who hasn't copied the scripts yet, I'll put the, that's the audio one. I'll just put that on screen for a sec if you want to check it out. Transform.up. The reason that I use transform.up, negative transform.up, is because transform.down was deprecated to save memory in the transform component. And really just doing negative transform.up is absolutely fine, right? So, yeah. Do force mode.force and force mode.acceleration have any difference except that acceleration doesn't use mass? No. The difference is that it doesn't use mass. Yes, here, hover motor script. There's the hover motor script. I'm going to actually zoom it out just so it can all fit on the screen a little bit. Sorry, zoom out. For those of you guys who want to copy off the screen, there it is. The car object is free on the asset store. Yes, Mero Sala. That whole package of assets, the sample assets, is free. Just search for sample assets on the asset store or find Unity, the Unity publisher, and you'll find a whole bunch of free assets. I am sorry, 26. Yeah, actually, not exactly an RPG, but I have been working on a tile-based, turn-based 2D game project for the past couple of weeks that will definitely be making its way to you guys soon, that could be totally adapted to an RPG type of format. Okay, cool. Well, it looks like the chat room is winding down. I'm going to go off mic, but I'll keep an eye on the chat. Thank you so much for everybody for coming out. I will be seeing more of you. Check out the new content coming on YouTube. And if you have, actually, maybe before I go off mic, if you guys have requests or ideas for things you would like to see, I would love to hear them. What are the problems you're trying to solve? What are the types of games that you're making? What would you like to see live training on? You know, beginner, intermediate, advanced, all that stuff. I'd love to hear it. Cool. Okay, I'm going to shut my mic off, but I'll keep watching the chat for a little while. Thanks, guys.